Hi, my name is Maddie Poch.
And my name is Reagan Wakefield, and this is our CS 2316 final project, using Spotify data and top charts to analyze music trends.
We wanted to examine different characteristics of popular music to understand why and how that music is so well liked. We also obtained data from different countries to add a cultural component to our analysis. And according to my personal Spotify Wrapped, I spent almost a month of 2022 listening to music. So this is something very important to me.
Spotify is a Swedish streaming service that utilizes its data structures to create playlist recommendations for its users and summarize their listening styles in annual Spotify Wrapped presentations.
Some metrics Spotify collects on its data are acousticness, danceability, and valence. Valence is actually a measure of how positive or negative a song sounds, with 1.0 being the most positive score a song can earn and 0.0 being the most negative score. Each of these metrics are giving a numerical number like the valence score and can be accessed through the Spotify API, which we did for this project. Chart 2000 is a website that collects data on the top music charts, and this is where we found our CSV file.
Here are some notable cleaning methods from phase 2. In the CSV file, we filled all NaN values with 0 using .fillNA. We removed rows that had a dash in the to or from columns. We also added columns for each country to assert if it was popular or not popular based on their numerical popularity score. Finally, we changed the format of the dates in the to and from column to a year, month, day format in order to create a datetime object. Using the datetime module, we found the number of elapsed month that a song was popular.
For our HTML source, we used a Wikipedia page containing the top artists with the most streams from the year 2013 to 2022. We used the Beautiful Soup module to web scrape this HTML code to get the years and artists from the HTML table. Some specific cleaning methods that we used were that some tables had citations, so we removed them using a slicing method. Additionally, some of the table entries had the number of streams listed in parentheses, so in order to get only the artist's name from the table, we had to use regex. And we wrote this data into a JSON file.
For the Spotify API, we needed to use a request.exceptions module to make sure the request didn't time out. We filtered rows from the CSV file to include only artists that appear in the JSON file that were web scraped from the Wikipedia page. We used the names of the songs and artists to search the API for the song codes. Then we used the song codes to request data from the API to obtain song characteristics such as tempo, danceability, and more. As mentioned before, our original CSV contained a numerical popularity rating for each song in each country. In phase 2, we created a popularity column for each country, asserting if it was popular or not popular based on the numerical rating. If the score was less than 100, it was deemed popular, and if the score was greater than 100, it was deemed not popular. The goal of this first insight was to determine which country's music preferences were most similar to the United States. In order to achieve this, we created lists out of each country's popularity column and zipped them with the US popularity column. If both elements of the resulting tuple matched, this indicated that a particular song was popular or not popular in both the US and the other country, and a count was incremented by 1. We created a dictionary where the keys were the country name and the values were the corresponding counts. The country with the highest count has the most popular songs in common with the US, so we found the maximum values in the dictionary and returned the corresponding key. We found that Canada has the most common music preferences to the US. This makes sense because the US and Canada are close together geographically and share a common history. We created a bar chart from the results of this insight using the Altair module. As you can see, Canada has the greatest number of popular songs in common with the US, with the UK not far behind. However, even France, the country with the least amount of common popular songs, still had over 200 songs in common with the US, showcasing that many popular songs are popular worldwide. The Spotify characteristics of energy, danceability, and tempo indicate songs that are fast-paced and high energy. The goal of this second insight was to find the artist whose songs had the most energy, danceability, and tempo, and see if there were any correlations. We read our CSV into a data frame and grouped by the artist name. We used the mean aggregate to average all the characteristics. We found the maximum values of energy, danceability, and tempo, and found that they all belonged to collaborations. This means that there could be a correlation between collaborations and energy, danceability, and/or tempo. This makes sense because collaborations tend to be upbeat and energetic.
For our third insight, we wanted to examine the correlation between how long a song is popular in months and the characteristics, danceability, energy, loudness, and a few others listed in our code. In order to do this, we used merged data from our CSV file and our Spotify API output. And the general goal of this insight was to determine which characteristics had the highest correlation with the length of time that they were popular. And in order to do this, we used Pearson's correlation coefficient, and we did this by using the .core method on our pandas data frame. The output is of all of the correlation coefficients in an array alongside the name of the characteristic.
All of these correlations are relatively weak, but when we look at the extremes, we can see that tempo had the greatest positive correlation and speechiness had the greatest negative correlation, which makes sense because sometimes the tempo of a song in being fast can make it catchy, so the song is able to stay popular for longer, whereas songs that are too talky might not be able to capture people's attention and annoy them for a while.
Our next insight uses a linear regression equation to predict the future average valence score of a song in 2025. We used the merged data set for this insight, and we grouped by year to get the average valence of all songs for each year. The output from this code is a best fit line with a negative slope, meaning that valence generally decreases with time. Additionally, based on this line, we were able to make a prediction about the average valence of a song in 2025,
which was about 0.39.
Which is relatively sad and depressed because the valence scores that are below 0.5 are closer to being more negative than more positive. This visualization is based on our previous insight, which is that the average valence of a song decreases as time goes on, as you can see by the downward sloping trend line on this graph. Looking at this graph paints a broader picture about the previous insight because you can see the high amount of scatter of these points on the graph. Although valence does generally trend down over time, you can see that the high amount of scatter indicates that this statistic should be taken with caution and that it is certainly possible that some songs could actually be happier over time. Additionally, our last insight was to determine which two characteristics were most positively correlated with each other. In order to do this, we created and annotated a heat map and extracted the values of this heat map, of this correlation heat map, and found the maximum value that was not equal to 1, which was about 0.75. Then we used the index of this 0.75 value to figure out which characteristics that this index lined up with using a series of if and elif statements that you can see below. We put both of these characteristics into a list and returned the two values of the list, which were energy and loudness, indicating that these two values had the highest correlation coefficient. Looking at our final visualization that's related to our previous insight, you can see that the value of 0.75 is the lightest non-1 value on our correlation heat map. So energy and loudness are the most positively correlated of any two characteristics. You can also see that energy and acousticness are the most negatively correlated. Both of these observations make sense because energy could come from the song's loudness, whereas acoustic songs often have relatively low amounts of energy and as a result would score lower on that front.
Thank you for watching.